This is one in a series of talks about the IOOF Cemetery in Jones, Oklahoma. Together, these talks highlight the cemetery projects that Allison Land and David Jones are working on. For this presentation, David will narrate, and the topic will be the latitude and longitude coordinates for the Jones Cemetery. We have the coordinates for every gravesite. Some people might be interested in how we got them, and that's what I'll talk about. However, I should mention that this talk is optional. It is possible to learn about the cemetery and to use the websites without knowing anything about how we got the coordinates. Plus, there's a bit of technical information here. As I mentioned, we have the coordinates for every gravesite in the Jones Cemetery. So what does that mean? What are latitude and longitude, and why are they useful? Well, by way of review, latitude and longitude provide a coordinate system to specify a location on the globe. Latitude measures an angle from the equator to the poles. Latitude at the equator is 0 degrees, and at the poles it's 90 degrees. If we look at the slide, Oklahoma is about here, so between about north 30 and north 40 degrees. Longitude measures east and west. By convention, 0 degree longitude runs through Greenwich, England, here. Looking at the slide again, Oklahoma is between about 90 and 100 degrees west longitude, maybe a little closer to 100 degrees. When there's a new burial, we find out what the block, lot, and site letters are. We use that information to look up the associated coordinates and add the coordinates to findagrave.com. As shown on the slide, that allows a user to click a link on a person's memorial that will open a map of the cemetery that includes a marker to show the location of the burial. The jonesoklahoma.us website also uses that information for the maps that it creates to show the burial locations for all of a person's relatives. The white squares with numbers are the relatives' burial locations. So that's what the coordinates are and how we use them. I want to take a few minutes to tell you how we got the coordinates. A good guess might be that we sent out a traditional survey team. We didn't do that. Some people might think that we were more up to date and used GPS surveying. We didn't do that either. Did we at least measure the coordinates with a consumer GPS or a cell phone? Well, no. This is more like it. That would be me sitting in front of my computer at home. Here are some bullet points about the coordinates. Since we didn't survey or directly measure the coordinates, I want to take a few minutes to tell you what we did do. This slide lists the major tools and techniques we used. They include Google Earth, interpolation, and a spreadsheet. The three of these interact and overlap, but let's start with Google Earth. This is a satellite or aerial photo of the cemetery from Google Earth. I've added some information to the photo, specifically the major subdivisions for the cemetery called blocks. There are 12 blocks in the cemetery. As we'll see in a minute, the blocks are further divided into lots, and within lots there are site letters. Block, lot, and site letter identify an individual cemetery plot. We'll work our way down to more detail. Specifically, let's look at Block 2 in the southwest corner of the cemetery. Zooming in even more now to the northwest corner of the block. And zooming in a little more. The small blue arrow is the cursor location. The cursor is positioned over the corner gravesite in the northwest corner of Block 2. In Google Earth, the latitude and longitude of the cursor location is continuously displayed in the lower right. That's too small to see here, so I've enlarged that bit of the screen in the inset. Remember when we looked at the globe, we expected the latitude for Oklahoma to be between 30 and 40 degrees north, and the longitude to be between 90 and 100 west? Well, for that specific cemetery plot, the latitude is 35.551832, and the longitude is 97.300 229 west. So it fits. Remember that number. We're going to use it again. We've been looking at satellite photos from Google Maps with north to the top. However, the cemetery layout uses west to the top, so we'll need to rotate our perspective. Note that Hiwassee Road is on the west side of this slide, and the cemetery road is across the top. I'll take this picture and rotate it 90 degrees clockwise, as shown in the black arrow. Just to get oriented again, Hiwassee Road is now across the top, and the cemetery entrance road is on the right. Here's the corner marker with the blue cursor in the upper right. The IOOF has an Excel spreadsheet with the cemetery layout. It's oriented like the previous slide with north to the right. The spreadsheet provides more detail from block down to the lot and site letter. Block 2 is in the upper left of the spreadsheet. Let me zoom in a little more so it's easier to see. This slide has all of Block 2 outlined in blue. There are 2 rows for each burial site. That's because the location is specified by lot and by site letter. For each of the row pairs, the top row has the lot. For Block 2, along the top row, there are 12 lots numbering 1 through 12, reading from right to left. 1, 2, over here to 12. The second row has site letters. Site letters are individual burial plots. There are 4 burial plots or site letters in each lot. The site letters are A, B, C, and D. In the upper row, Lot 1 is highlighted in yellow. In Lot 1, site letter A is highlighted in light green. Notice that for the second row of burial plots, the numbers read from left to right, 13, 14, all the way out here to 24. You remember that we used Google Earth to get the lat long for the burial plot in the corner of Block 2. I'm sure you remember the number, but it's repeated here with an arrow pointing to Lot 1, site letter A of Block 2. We won't go back to the aerial photo, but if we go to Google Earth and position the cursor on the other end of the row, in Lot 12, site letter D, then we see the coordinates for that plot in the middle of the page, here. That's the coordinates for Block 2, Lot 12, site letter D. If we look carefully, we see that the latitude is different. 35.551832 for the first point, and 35.551294 for the plot at the other end of the row. When we look at longitude, it is 97.300229 for both points. Why didn't it change? Right, longitude measures east-west. We didn't move east or west. We went straight south down the row. Again, the 3 things we mentioned earlier tend to overlap and work together. However, now we're going to talk about interpolation. By using Google Earth, we have a technique to find the latitude and longitude for individual grave sites sitting at our computer. And we've already done 2. However, there are over 9,000 grave sites. We need to find another way. This slide shows the technique we used, which is interpolation. It's a busy slide, so we'll take our time. Remember that there were 12 lots along one boundary of Block 2, and then each lot had 4 burial sites. So there are 12 times 4, or 48 burial sites on each row. Would you think that you could measure the difference between the latitude and longitude for graves that are side by side, just a few feet apart? Granted, there's not much difference. You have to use a lot of decimals, but it's there. Let's figure out what it is. Here are the 2 latitudes from either end of the row that we got from Google Earth. 35.551832 and 35.551294. If we subtract the 2 latitudes from either end of the row, the difference is 0.000538. That's the total difference between one end of the row and the other end of the row. What if we want the difference between two grave sites? How do we get that? Well, we have to divide that number by the 48 grave sites. When we do, here's 0.000538 divided by 48 is equal to 0.000011208. It's not much, but that is the change in latitude from one burial site to the one next to it. From there, we just systematically tweak each site by that amount as we go down the row. In the example, Lot 1, Site A is 35.551832. That's the latitude we picked off Google Earth. For the plot next to it, Lot 1, Site B, we changed the latitude by the 0.000011208 we calculated and get 35.551821. So for Block 2, Lot 1, Site letter B, we didn't directly measure the coordinates from Google Earth, we calculated them. So now we're calculating rather than measuring directly. Even so, we still have those 9,000 plus burial sites to calculate, and the method isn't much faster than directly measuring it on Google Earth. Our shortcut was a spreadsheet. I'm sure you are familiar with spreadsheets, but just in case, let's do a quick review. This is a screenshot of Microsoft Excel, which is a spreadsheet. The spreadsheet is a grid of columns and rows. The rows have numbers down the left side, and the columns are labeled with letters across the top. The intersection of a column and row is called a cell. Right now, the cursor with the green outline is in cell A1, and it's highlighted. Here's an example of a simple calculation in a spreadsheet. We have our cursor in cell B2. In the screenshot on the left, we type equals 3 plus 2. The screenshot on the right shows what we get when we hit the enter key after typing our formula. We get 5, the result of the formula we typed. Here's a slightly more complicated example, but far more useful. This time we type 3 in cell B2. In the cell next to it, cell C2, we type equals B2 plus 2. You can't add B2 to anything. What it's doing is taking the value of the cell in B2, the 3, and adding 2 to that. When we hit the enter key, we get 5 as shown in the screenshot on the right. Note that our formula is in cell C2, is B2 plus 2. Now we place our cursor in cell C2 and copy. We copy cell C2 and paste it in the 6 cells to the right. Here's the result. Each cell has the number 2 added to the value of the cell to the left of it. The cursor is in cell I2. The formula in cell I2 is shown in the red circle up here, equal H2 plus 2. Note that the formula has changed. It is H2 plus 2, not the B2 plus 2 that we typed at first. The spreadsheet is using the relative position of the cell for its calculation. That serves our purpose well. We can copy the formula and get the results for a whole row at a time. We aren't limited to simple numbers like 3 plus 2. Here we have typed in the latitude values that we got from Google Earth. Now when we copy and paste, we get the latitudes for a row of grave sites, or the coordinates are 48 plots in a single operation. One more confession. I didn't measure the endpoints of every row of graves in the cemetery. Instead, I measured the corner points of each of the 12 blocks. I've highlighted 2 in this photo. The 2 red arrows, here and here, mark the diagonal corners of block 2. The yellow arrows are the corner points of block 9, here and here. The formula that I copied and pasted was a little more complicated because it tweaked both latitude and longitude at the same time, but it used the same principle. So 12 copy and paste operations for the 12 blocks, and that covered the entire cemetery. Now that we have all the coordinates, we added them to every memorial on findagrave.com. Also, the Jones, Oklahoma Cemetery.us website uses a built-in table of coordinates to make its maps. However, there may be some organizations or individuals that could use the coordinates, and we do have a spreadsheet available. This is the first sheet of the spreadsheet. It has some information to read and a button labeled Find Lat Long. Along the bottom of the sheet, there are tabs that are labeled All and then each of the block numbers. If we click on one of the tabs, we get a listing of the cemetery plots, including the longitude and latitude. We can scroll down or use the filters at the top of each column to find coordinates for a specific plot. If we click the Find Lat Long button on the first sheet, then we get this pop-up form. To use it, click on the desired block, site letter, and lot in the three list boxes here, here, and here. Then click on the Find Coordinates button, and the associated coordinates will be displayed in the bottom two boxes on the bottom of the form, here and here. That's a brief summary of how we came up with the coordinates for all of the cemetery grave sites. Truthfully, it didn't provide the very best solution. All those survey and GPS solutions that we mentioned at the beginning of this talk would be more accurate. But we didn't want perfect to be the enemy of good. We have something that will at least put a person in the general vicinity of a grave site. And there's still an opportunity for a person or organization that is looking for a project. Thank you.